In topic 3, we have a test for factors. We are asking, the skill we're trying to build up to here is we're trying to factor this, which will mean we're trying to divide this, which will mean that we need no remainder, which will mean we need to be able to find the x-intercepts. Now, a lot of these ideas are very much connected, and through this idea, we start building upon this. So essentially what we're asking you to do is to say, what happens if we divide by x minus 2? Or we're basically trying to say, is this a perfect factor? Which is exactly the same thing as saying, is x equal to 2? Because if you put 2 here, 2 minus 2 creates a 0. Zeros are known as x-intercepts. So when we ask if something's a factor, we're basically saying, is x equal to an x-intercept? Which is exactly what this test is. Let's put 2, the potential x-intercept, into every x. Let's see what happens. What's it going to say? And so when I put 2 cubed plus 4 times 2 squared plus 2 minus 6, it's going to come up to 8 plus 16 plus 2 minus 6, 24, 20, it's going to come out to 20. So no, that's not an x-intercept. This is like a y-coordinate. We call it a remainder, but it is also a y-coordinate. And so we basically just figured out that this graph, this cubic graph, goes through the coordinate 220. So that's not an x-intercept. So no, it's definitely not a factor. How about when x equals negative 2? Will this work? What does this tell us? So the notation says, well, let's figure out what p of negative 2 is. Let's let x equal all the negative 2's. Just negative 2 cubed, negative 2 squared, negative 2 minus 6, which comes out to negative 8, plus 16, minus 2, minus 6, and boom, 0. The remainder we need, and the remainder we always want. So this is evidence to say that this function goes through the coordinate negative 2, 0. This is evidence that the remainder, if we were dividing by this factor, will be 0. And evidence to say we now know that the x-intercept of this graph is negative 2, which means that the factor is x plus 2, and that would be one of the ways to break down this cubic. One of the factors, one of the simpler ways to break down that cubic. And this is precisely what example 2 wants us to do, but which is a whole lot less work. If you have the picture, well, you don't have to do near as much as that work up there. We can do much quicker. We can be much quicker here. So this is a notation called p of 2. Saying, is this a factor? Is this a factor? Well, is this an x-intercept? P of 2. Well, let's go to the graph. P of 2 is right here. Is that an x-intercept? No, not even close. Way too high. So this equals 8, and so no. The remainder equals 8. It's a y equals 8. Oops. That's not an x-intercept. Below, well, let's talk about p of 1. What's going on at p of 1? X equals 1. Well, nothing much different. It goes through 1, 6. Is that an x-intercept? No. So therefore, is this a factor? No. For all the same reasons. The remainder is equal to 6. This is a y-coordinate equals to 6. This is not an x-intercept. What about negative 2? P of negative 2, beautiful. Negative 2 is a 0. 0, yes. Because the remainder equals 0. The y-coordinate was 0. Negative 2 is an x-intercept. All the things we want when we're factoring.